What is an ellipse and how to graph it by hand? So I'm just going to do a quick demonstration of how to do this. I'm going to maybe show you some things you haven't seen before, but maybe you have. This is just a quick review. A and this other blue point, these are foci for this particular ellipse, E. Um, so what's the standard form of the equation? So here's the standard form of the equation, x minus h squared over a squared plus y minus k squared over b squared equals 1. H and k are the centers of our ellipse. A squared, b squared are major and minor axes, depending on which, the lengths of your semi-major and semi-minor axes, depending on what's what. And I'll go over that here in a second. But I think it helps us to just take a look at, step back and take a look at an ellipse. So one thing that I always love is if you take a circle and we connect the perpendicular bisector between a point inside the circle and a point on the circle. So you can see that pink line is a perpendicular bisector between the two. And then turn the trace on. And E, just so you know, E is a point on that line directly between A and the point on the circle. So let's just take a look at this. So it's tracing out that tangent and it's tracing out that point E. And take a look at how it creates that ellipse. Okay, kind of a neat geometric representation of it. So what happens if you maybe get the center of the circle and the point closer together? Let's just take a look and see what happens. So we'll go ahead and move this around the circle. And I'm moving that point is all I'm doing. And if you take a look at it, it's a less eccentric ellipse. Here's your two foci still. It's almost a circle. It's slightly wider than it is tall. And what's even neater about the whole thing is you can pull this thing really close to the edge and it's going to make a super skinny long ellipse, which would be a very eccentric ellipse. Not really going to talk about eccentricity right now, but if you take a look at that, it makes more of the oval shape that we're used to seeing. And you got to think, what would happen if we pulled that point, that foci, outside of the circle? So let me move things. So notice nothing's really changed. The point on the circle and that point that I did have, these are still, this pink line is still a perpendicular bisector. And there is still a point along the line between A and here and this point on the circle, and take a look at what happens. So there it is, it's following that line. And it's creating a hyperbola. So kind of a neat deal. We'll talk about hyperbolas later. You can also look at this in terms of sliders, and I'm not going to spend a lot of time here, but here's the equation. Here's my sliders for A and B, the points on the bottom. Notice I have everything set to 1. And so if I want to move H to the right, notice my circle moves to the right. So H is 4, it's x minus 4 here. Notice on the x-axis is 4 over. If I move it to negative 4, or maybe negative 3.35, notice it's negative 3.35 on the x. It's x plus 3.35 inside of there. Same with k. So if I move that up, maybe move this back to, well, you could move it to 0 if you wanted to. Well, we'll move it to 2. So we shifted it right to with h. Can't quite get it perfect. Okay, close enough. And then this, as you move it down, it goes down k. The k goes up 2.8, 3. Notice it's up 3 right here. So the center, that changes your center. Now if you change A and B, I put A underneath the x value, and notice if I change A a to 2, that makes this 4 because it squared it. And this length here from the center to the outside is 2. So that's your semi-minor axis, or semi-major axis, excuse me, that's the long side. And if you change B to maybe 5, okay, notice it's 25 there. I'll pull that out. And your semi-major axis now would be 5. So from here's the center down, it's 5. And I'll just go through all that now. And I think the best way to go through this exam is with an example. So we're going to start out with, first off, H and K come out of the 3 and the 4 here. And so my center of this ellipse is 3, negative 4. You change the signs coming out of the parentheses. So we'll go ahead and graph that. We'll go right 3, 1, 2, 3, down 4, and that's the center of my ellipse. And I'll extend the page. There it is. There's the center of my ellipse, 3, negative 4. Whoops. Then the numbers on the bottom, 25 goes underneath the x value. So that's saying A is 5. So we're going to go, since it's under x, we're going to go right and left 5. And B, since that's 9, B is 3. And so we can go ahead and do that. So since 25 is under the x, we're going to go right and left 5. Oh, and I see the center, my center moved when I did something funky to that. So 3, negative 4 was my center. That's right here. And then we're going to go right and left 5 for my semi-minor axis. 1, 2, 3, 4, 5, right there. Left 5, 1, 2, 3, 4, 5. And then we're going to go up and down 3. So 1, 2, 3, make a point. 1, 2, 3, and make a point. Kind of ran off my graph. And so here's my ellipse. And my major axis, that length is 5. My semi-minor axis, that length is 3. And it's the same in both directions. So this length is 5. This length is 3. And so my minor axis is 6 long, my major axis is 10. These out here, each of these points are called vertices. And the only thing left to really find is the foci. So the foci in an ellipse can be found with the following equation. And again, A and B, doesn't matter which one of these you call A and which one of these B. This could be A, this one could be B. It just depends on what it's under. So in our case, it's underneath A. I called this one A. It's underneath the X. It's going right and left. B is underneath the Y. It's going to go up and down. And so we're going to, so if you set this up, the absolute value, just make sure it's always positive, would be 25 minus 9, which is 16. So c squared equals 16. And so c is equal to 4 if you square rooted both sides. So that's that, just to show my work. And what that 4 is that's the distance to your foci along your major axis. So you would count to the right 4. Here's your center. Count to the right 4. 1, 2, 3, 4. And there's one foci. Left 4. 1, 2, 3, 4. And that's your left foci. The only thing left to find is eccentricity. And eccentricity, we represent it with an E, is C divided by the length of your semi-major axis. So in our case, it would have been A. So our eccentricity in this case is 4 divided by 5, which is 0.8. So the closer we get to 1, the more eccentric this thing is. The closer we get to 0, the more like a circle it is. And there you have it. So that's pretty much all the important information. Now, if you've gotten to this point, you probably know, you've seen this maybe before. And so give this a shot now. Try this out, and I'll go through the same process. So stop the video, see if you can figure this one out, and graph all the important parts. Okay, so to graph this thing, your center is -2, +1. So I'm going to go left 2, up 1. There's the center of my ellipse. Since 9 here, I'm going to call it A. A is 3. So you take the square root of 9. So we would go right and left 3. There's 3. There's 3. So those are my vertices along the X, since it's underneath the X. My vertices along the Y, since it's underneath the Y, B would be 4 in this case. So we're going to go up and down 4. 1, 2, 3, 4. And so let me go down 4. 1, 2, 3, 4. And so my major and minor axis are up and down instead of left and right in this case. And so I'm just going to rough sketch this. It doesn't have to be nice. We're just getting a general look of this thing. And then the next two things, again, you find the foci, distance to the foci. So c squared equals the absolute value of a squared minus b squared. So c squared equals, in our case, 9, the absolute value of 9 minus 16. So c squared equals the absolute value of 7. And so c is equal to the square root of 7, which is about, now that since we're just getting kind of rough estimates, a rough sketch of this thing, around 2.65. So that's telling me to go, since it's always the distance to my major axis, I'm going to go up about 2.65, so that's this distance here, and then down 2.65, so right there. So those are approximately where my two foci lie. My eccentricity then would be c divided by your major axis, or 2.65 divided by 4. And so if you divide that by 4, you get approximately 0.66. So my eccentricity, not as eccentric as the last one I did. And that's everything you'd need to find if you're rough sketching these. In the next video, I'm going to show you how generally to, if you don't have it in standard form, how to put it in standard form and then graph them. And I'll also do a video on how to find the equation of an ellipse. Now, one last thing before we get into this, GeoGebra is really nice because you can just plug this thing into GeoGebra and find the equation. So and so you can see I plugged it in over here on the left in the input. If you hit enter, it'll graph it quick. I'll move graphics view so we can take a look at this thing. And you can see that it's roughly the same thing I had in the other equation. So kind of see them both there. Notice it doesn't give you the ellipse. You'd have to find that on your own. And it doesn't give you the eccentricity. So hopefully this helps you, and I'll see you next time.